Hello, this is exercise 19b on displacement, velocity and acceleration. And this would be, I suppose, quite like some of the maths you do in physics. There is an overlap between maths and physics. And this is what we in mathematics call mechanics. Mechanics involves a number of things which involve, for instance, speed, distance, time, acceleration, forces. So things that you will see in science, and in particular the branch of science called physics. So some of you who are doing lots of physics or have done in the past may find this all straightforward. And as we go through the other mechanics topics, you might find them quite straightforward as well. But it will slowly become slightly different from what you see in physics, in as much that you'll find there's obviously a more mathematical look at these things rather than looking at the properties, the forces, why things happen. We in maths we generally just care about the maths behind what happens. So anyway, let's have a look at this. I've got a couple of starter questions for you first of all. The first one says, how long does it take the driver of a car travelling at 60 miles an hour to travel 100 miles? And you should remember this formula. Basically, it's speed equals distance divided by time. And you may even remember it as a little triangle. I always put the D at the top. I put them alphabetically, DST. And as long as you use that formula the way you've been taught to use it, you should be able to do those two questions. So the second question says, I travelled 21 kilometres in an hour and 10 minutes. One way to think of speed is how far you would go in 1 hour. Assuming it's in miles per hour or something. So it's how far you would go in 1 hour. So with that in mind, you might be able to work out these other bits and bobs. So anyway, I'll try and do these questions. I'll pause the video now. So look, yeah, I'm hoping you've done that. I'm going to do these questions here. Hopefully you'll get the same answers as me. So here we go. What is it? It was travelling at 60. So that's my speed, I suppose. That's the S equals. And this is my distance. So my time, if you just rearrange that equation, is my distance divided by my speed. One problem you get with this is time. You'll get decimal time when you do this on the calculator. So it's distance is 100 divided by 60. This will give me an answer in hours. So 100 divided by 60 equals, and it says 5/3. So 5/3 or 1.67 maybe. Hours, or, well, as I say, it says 5/3, so that's 1 2/3. Now, if you just think to yourself 1/3 of an hour, it's got to be 20 minutes. So this has got to be 1 hour, 40 minutes. So I reckon it's quite easy to get 1.66666 out this answer, or 1 2/3 on your calculator. It's harder to work it out in hours and minutes. So see if you can get your head around it. Notice what I did. I thought of an hour at 60 minutes, a third of an hour, therefore it's 20 minutes, and I had 2/3, so 1 hour 40 minutes. The cycle this travels 21 kilometres in 1 hour 10 minutes. What's his average speed? Well, again, you will be a bit careful, because one way some people might do this is they might do 21, that's his distance, and his time. They might convert it just into minutes. So this is 60 and this is 10, and that's 70. And if you do this, 21 over 70, so just doing it now, 21 divided by 70 is 3/10, or 0.3. Now that's kilometres. I convert it to minutes. That's kilometres per minute. So what if I probably want the answer in kilometres per hour? It doesn't actually tell me to, but I'll probably do. So I then have to times that by 60. So times by 60. And it gives me 18 kilometres per hour. That's actually the answer. Now the alternative is to do 21 and to say to myself, 10 minutes is like a sixth of an hour. There's 6 lots of 10, basically make a whole hour. So this is like 21 divided by 1 and a sixth, or 21 divided by 7/6. I'm not sure if you like that. There's other ways to do it as well. So I'm just doing the same thing. And it gives me 18 straight away. So if you want to do it that way, you can instead. There's a variety of ways of doing that. So I could probably easily have thought of a third way instead. Anyway, so there's my answer, 40 and 18, so everything's good there. A little word about distance and displacement. Displacement measures the change in position. So it's not the same as distance travelled, and some people get confused by this. And there's a little example of this. If I move 2 meters to the right, so let's imagine me, and try and find where my pen is. So up here I can just draw a little line. Here's me, I move 2 to the right. So you can see 1, 2. And what's it say then? But then 2 meters left. Alright then, so I go back again. Dum, dum, dum. Oh, I'm back where I started. Notice I have actually travelled 4 meters. My distance travelled is 4, but my displacement is 0. So displacement measures my change in position, i.e. I've not changed anywhere, I've not gone anywhere. I was at 0, I moved 2 to the right, I moved 2 back again. My displacement is 0. If I move 2 more meters to the left, well, you can see 1, 2. I've now got a position of -2. So my displacement is -2. And notice my distance is now 6. Notice my displacement isn't 2 because 2 is over here. So you can have a positive and a negative displacement. Distance travelled is always a positive number, or 0 I suppose. So bearing that in mind, I've hinted here, it's always useful to draw a sketch. At points A, B and C lie in that order, so I'm tempted to draw a little picture at the top, but I don't have much room here. Oh, that looks like I'm on a hill. What's that? That was A, then B, then C. AB is 150 meters. BC is 260. The direction of positive values is we get from A to B. A travels from A to C. Alright, and so when I do this, I go from A to C, and then from C back again to B. So what's my displacement from C to B? From C to B, well, I'm going 260 to the left. I reckon that's -260. What's my final displacement from A? Well, I went all the way over there and then back again. So I reckon that's +150. I don't need a plus. I just wrote that to show that I've moved to the right. And the total distance travelled, well, that's just, what, 260? Sorry, I've just realised I nearly went wrong here. So it is 260. Everything's right, but on the third one I nearly went wrong. So the total distance travelled is 150 plus 260, and then 260 again. So that's 150 plus 260 plus another 260. What's that? 520, 670. And that's a positive number. And there, I've got all the right answers. Good. Now, speed and velocity, these are not the same either. Speed is the rate of change of distance. That basically means rate of change of distance as opposed to displacement. So that basically means in my formula, I suppose, I had before speed equals distance over time. Whereas if I was doing average velocity, I would have to do displacement over time. Both of them written in meters per second or kilometers per hour or things like that. So notice my two formulae here. Total distance travelled over time for speed. Final displacement minus the initial displacement. This is like a change in position divided by time. So just bear that in mind. You might want to make notes of all these formulae, write them down in your book. And they will be useful. Acceleration formulae. So we've also got acceleration. Acceleration is the rate of change of velocity. Notice the funny units, ms to the -2, sometimes written m over s squared, or kilometers per hour squared. It's always square units here because it's rate, and for that reason you sometimes see it written like this, meters per second per second. This is the formula, final velocity minus the initial velocity divided by time. It's a change in velocity over time. So these are the formulas that we need to write down and copy down and use in our notes. So make sure you have copied them down. So we've got here this question here. We've got 3 points A, B and C. And it says it starts at A, moving towards B, and it's got a speed here, it says, of 2.5. So this is the speeds. Moving towards B, so it's going that way initially. 6 seconds later, so it takes 6 seconds to do this. It passes through B with a speed of 3.1. So the time it gets here, it's got a speed of 3.1. After 7.5 seconds, it reaches C, where it stops and starts moving back. Okay. Okay, I like that. So it then starts going back, and it passes, it passes 8.5. So on the return leg, it takes 8.5 seconds to get back to B, and then a speed of 4.1. Okay, so it says find the average velocity of the particle moving from A to B. Now remember what we said. It's just worth going back to this. What is average velocity? Average velocity, it says, is the final displacement minus the initial displacement. How far has it gone? Divided by the time. So if we just go back to it, from A to B, it's done 18 meters. Definitely, it's all gone in one direction. And it took 6 seconds. So I think this is just 18 divided by 6. Is 3 meters per second. The average speed of the particle for the whole journey. How far has it gone then? The total distance now required. I've gone 18. I've gone 26, and I've gone back again, and that 26 was repeated, so that's 52. I think I've gone a total distance of 70. How long did it take me? 6, 13.5, 14, 22 seconds now, I think. So it's 70 divided by 22. 70 divided by 22. And I get, not very nice, 3.18 meters per second for my average speed. Notice for the whole journey of the time. What's my average velocity? Well, my average velocity is actually much easier. I started there, I ended there. So again, it's only 18 meters I've travelled. How long did it take me? It took me 22 seconds. So 18 divided by 22. 9/11, so 0.818. 0.818 meters per second. Don't know if they're right. Good, got them all right. Last example, actually, this. Convert 2.6 meters per second into kilometers per hour. Well, first of all, I'm going to show you the traditional way of doing it. You want to make it kilometers per hour. So your first job is to say, well, this is meters per second. 2.6 meters in a second. That's how far it travels. So in an hour, well, let's first of all do it in a minute. You times by 60. So I'm going to do 2.6 times by 60. That says 156. So it's 156 meters per minute. And if I times by 60, this will be meters per hour. So I times by 60 again. You can just do it in one foul swoop and times by 3,600. But I get 9,360 meters per hour. But of course I now want to make it kilometers per hour. And to do that I divide by 1,000, sorry, nearly got a terrible mistake. So it's 9.36 kilometers per hour. And the other one says it's 170 kilometers per hour squared. And it wants me to convert them into meters per second squared. So again, first job is I'm going to make this. I'm going to make it 170,000 kilometers. Meters per hour squared. I've basically timed that by 1,000 to get that. And then I suppose I've got to worry about units. And the one thing I would say is be careful. It'd be dead easy to think if I divide by, well, 60 and 60 again, I'll get from seconds to hours, or hours to seconds rather. But I've got to be careful because of the fact that this is effectively squared units. So I've got to divide by 60 like I did before. But I've got to square that because it says squared here. So it's 170,000, and I'm going to have to divide by 60 times 60 squared. And if I type that into my calculator, I get, so 170,000 divided by 60 times 60 squared. I get 0.0131. That's something we can talk about in lesson perhaps. And that's what I got as well. Notice the rather tricky part of that. Remind me in class, this is something I want to show you. There's a beautiful button here, and I want you to be able to use it. But for now, that'll do, and we'll have a look at that. All the best.